Hello and welcome to CSE 468 Lab 2. Right now I am executing my Task 1 script. It basically just lists out all the commands that are done in Task 1, installing it, doing the OpenSSL-H ENC, which shows you all the encoding options, and then listing the ciphers. And now it's testing the it's doing a benchmark for the OpenSSL speed on this VM. Basically, it all rounds out to about 3 seconds. I executed a run before this one, and I let it go for a couple of minutes, and everything just said 2.99, 2.98, so 3 seconds is the bench. Now I'm going to execute my task 2 script, which is setting up the certificate authority. I have already created the lab 2 directory, as you can see, and my task 2 script file just basically moves the OpenSSL conf file into this directory, lists the directory, and then executes the command for creating your own self-signed cert, the OpenSSL rec-new -x509 -keyout ca.key -out ca.cert -config OpenSSL conf, and right now I'm entering all the necessary information for creating that cert, such as the country name, the state, the organization, etc. I also created all of the directories necessary for the OpenSSL conf file. I also modified the default dir entry to be the directory I'm in, which is lab02. So in this directory, there's a certs directory, a CRL directory, an index.txt file, and anything I need to create this self-signed cert. I obviously used a fake email address. And also the passphrase was the default passphrase. All right, now we're moving on to task 3. Right now I'm going to show you the script file that I wrote. It's basically just a executable file that has all the commands that are listed out in the lab content document. The first one is a OpenSSL gen RSA -des3-out server.key 1024, which just generates the public-private key pair for the client. The client is SAT4812sever.com. I realize now that it should say server, but I saw sever as the first company name in the instructions, and that's what I used. And for any passwords, I use the default password that we have for the class. Anywhere that it asked for a company name or something like that, I used the URL SAT4812sever.com. Just entering the information it needs, setting the challenge password. And this is all in the process. This is also the process of generating a certificate signing request that I will then issue a certificate for once I enter the passcode for that key. Now I'll sign the certificate. And there it is. The certificate has been created. Now I just have to send it to the client. This is the output of the certificate. We're moving on to task 4. Right now, I've previously run all the commands needed in task 4, so right now the web server is currently running. So I'm just going to show you the little script file that I ran to start all of this. It's just the copying the server key, and then putting the certificate in that key to create a permissions file, and then starting the server with that permissions file. As you can see, I already navigated to the URL, but just to show you that it actually works, I'm going to go to https://sat4812sever.com because I used sever instead of server, and then :4433. And look, it's untrusted because I'm using a self-signed cert. And as per the instructions, we are not supposed to add the exception, so we are told to manually load the certificate into our Firefox browser, which is what I'm doing now. Advanced, go to certificates, go to view certificates, and import. Then I'm navigating to the folder where the ca.cert file is located. And then I say, allow this CA to identify websites. Click OK. And reload the page, and we have things. It looks like the output is the cipher supported. Now I'm going to start the web server again, so that I can run the test described in the document by navigating to all the different URLs. Let's enter the password. All right. First one we're going to go to is https://sat4812sever.com. I noticed that there isn't a port 4433 specified. I didn't put the port just because that's what the assignment said to do. But if it did, I just wanted to let you know that it was successful. I could successfully navigate to sat4812sever.com :4433. But as you can see here, without the port 4433, it's unable to connect because the server isn't listening on port 443, which it uses for default HTTPS traffic. The next URL is localhost :4433, and since the web server is being run on localhost, it shows the certificate could not be validated because it's a self-signed cert. The certificate is already added to Firefox, so I don't know why it still showed this warning. It's enabled to validate websites, but it can successfully navigate to the page. It just says that the connection is untrusted still. I didn't add the exception at all. I just found it odd. The next website is https://127.0.0.1 :4433. It's just localhost again. Get the exact same thing. And then the test after that was the IP of the server itself. Now we're on the Kali Linux machine. The server is running on the Ubuntu VM, but whenever I try to navigate without the :443, it doesn't successfully navigate there. That's obvious because it's not listening on port 443. And all of the localhost URLs will not be able to connect to anything because the web server isn't being run on the local host. It's being run on a different virtual machine. So it doesn't know what to do with localhost traffic because there's no server running. Now we're going to the IP of the machine itself, and unable to connect again. And finally, what we're going to do for task 5 is the performance test of the RSA and AES ciphers. I made a simple script file called task 5. It has the two commands, OpenSSL speed, RSA, and AES. Just running that now. In running this test, everything came out to 10 seconds for RSA. What it does is it does a 512-bit, 1024-bit, etc. private and public RSAs for 10 seconds. And each one of these took 10 seconds, both for public and private. And now that is completed, now it's going to run the speed test for AES. And in running this, I found each one of them, each run took 3 seconds, showing that AES is much faster than RSA, but that could mean that AES is less secure. So, yeah, thank you for watching. I do apologize for the length of this video. Just want to get everything in here. So I will see you for the next assignment. Voila.